Hello grade A's, how are you doing? I hope you're doing great. Okay, this is Teacher Smile, and again today we are going to talk about algebraic equations. But we are not going to talk about the equations that we've been talking about so far. We are going to talk about different types of equations still under algebraic equations, but we are going to deal with those with exponents like this, and that. There is a golden statement that I want you to remember when you are dealing with these questions. That golden statement is if the bases are the same, then the exponents are equal. Okay, so if the bases are the same, then the exponents are equal. That's what we want to apply in each and every one of these questions. So we are supposed to understand that if the bases are the same, then the exponents are equal. If the bases are not the same, is it possible to try to make them the same? Because if we make all the bases to the left-hand side and to the right-hand side, if they are the same, then I will not have any worries. It means that whatever I need will be right before my eyes. So let's try to solve these equations. Remember, when you are solving equations, you are trying to make sure that you are left with something that looks like x is equal to something, right? That's solving equations. If we are saying if the bases are the same, then it means that we need to know what bases are. And if we are saying in that case exponents are going to be equal, we need also to know what exponents are. If I am given something like 2 to the power x, this number at the bottom is known as the base. This number at top, is known as exponent. So this number at the bottom is the base. That number at top is the exponent. So let's look at number 1. Are the bases the same here? Okay, number 1, are the bases the same here? We are dealing with 2 to the power x is equal to 2 to the power 3. Are the bases the same here? What's the base here? 2. What's the base here? 2. Remember, the base is this number that is sitting on the ground. So this is base, this is base. So both of them have the base 2. So it means that the bases are equal. So the exponents are also equal. Then it implies that this arrow means it implies, if the bases are equal, it implies that the powers are also equal. The powers are these exponents. So we've already solved that. That's cool. Let's go on to the second one. Number 2. Are the bases the same? 3 to the power x is equal to 3 to the power 5. Are the bases the same? This base is 3, that base is 3. So if the bases are the same, it implies that even the exponents are also equal. Okay, let's skip them and go to number 8. I'm not doing them in order. So 2 to the power x plus 1 is equal to 2 to the power 2x minus 1. Are the bases equal? What's the base here? 2. What's the base there? 2. So the bases are equal. Then the exponents, it implies that the exponents are the same. X plus 1 is equal to 2x minus 1. Wow, but now we don't have our x, so we have to solve our x the way we talked about in other equations. How? by making sure that we collect the friends to go to the same side. So this x needs to go to the other x, and this one needs to go the other side. And remember, every time when you cross the equal sign, your sign changes. So here we are left with 1, and it's positive 1, positive 1. This one was minus, and when it crosses the equal sign, it becomes plus 1 is equal to, this is 2x, it's positive, we write it. What's coming is this x, and it crosses this equal sign, it becomes minus x. What's 2x minus x? You have 2, the x, and then you subtract one of them. So you are left with how many? You are only left with 1x is equal to 2. Here we go. Maybe if I am to write starting with x, I'm just saying therefore my x is equal to 2. You get that? Okay, let's have a look at number 3. 2 to the power x is equal to 4. Are the bases the same? They are not. So I have to try to make the bases look the same. So is there any way of writing this 4 in a way that this base will be equal to that base? So let's think. This base is 2. So I can start by 2 to the power 1 is 1. It's what? We can start with 2 to the power 0. That's 1. 2 to the power 1, that's 2. That's 2, yes. And 2 to the power 2, that's 4. Exactly, that's what I want. So I'm going to write here 2 to the power x is equal to, instead of writing 4, I can write 2 to the power 2. And now the bases are the same. It implies that our x is equal to 2. It implies that our exponents are also the same. Okay, we don't have d here, but I'm just, looking at that one. Let's say we are given 3 to the power x is equal to 81. Are they the same? No, they are not. So what am I going to do? You are going to think in this space. 3 to the power 1, 0 is 1. 3 to the power 1 is 3. 3 to the power 2 is 9. 3 to the power 3, that's 27. 3 to the power of 4, that's 81. So instead of writing 81, I'm going to write 3 to the power of 4. You see, it saves me if I know this. So it implies that my x is equal to 4. Problem solved. So how about you try the rest of the questions here and try to see how you can come up with the answer. Otherwise, that's what you do when you are solving the equations with exponents. Make sure that the bases are the same. Thank you so much. Goodbye.